So following on from the previous video, we were trying to work out dH by dt for the cone, and we got to this stage here where dH by dt for the cone is given by this here. So what that means is that when at that precise moment in time when the height is 6 inches above the bottom, dH by dt will be given by this. Okay, so this here is in a way the speed at which it's falling. Okay, but we need this negative here to indicate that it's going downhill. It's going downwards. Okay, now we need to consider for the cylinder here. Okay, so don't forget it's dripping. The amount of volume coming in is given by this, meaning dV by dt is given by 10, and this time because we're gaining in volume, the dV by dt will be positive. Earlier in the previous video, dV by dt was negative 10 because we were losing coffee. Now we are gaining coffee. So dV by dt in this case will be positive 10. Okay. Now look at this. The volume of the cylinder is given by this. Now try to understand what's going on before we use implicit differentiation. So try, for the cylinder, look what's going on here. Well, it's the coffee is being dripping in here. So over time the volume will change with respect to time. So V is a function of time. So as the coffee is dripping in, over a period of time, H is dependent on time. H will vary, the height will vary. So H is a function of time. Now, as it's dripping over a period of time, the radius is not a function of time because the radius will always stay the same. It will always be 4, and then over a period of time, a second later, the radius will still be 4. A minute later, it will still be 4. So R is not a function of time. So when you come to differentiate it, treat R as a constant. Okay. So we're here. We need to use implicit differentiation. So differentiator, it will then give you this. So we are differentiating it with respect to time. So this will become this. Don't forget, R is just a constant. So when you differentiate this, it would be this, and then H would, because H is a function of time, we need to stick this dH by dt. So from here, it would take us to here. Okay. So the dV by dt, remember, is positive 10, so that will give you this. This here is what we want to know, but then we still need to know the radius at that precise moment in time. Now, we still need to know the radius at that precise moment in time, and that precise moment in time is when the height is 6. Well, when the height is 6, the radius is always the same anyway, 4. Okay, so but you do need to consider it at this precise moment in time when it's 6. Okay, in this case you're just lucky that the radius is always 4. So hang on. So dV by dt is positive 10. This is what we want to know. And at that precise moment in time, the radius is 4. So we need to put 4 into R. That will then take us to here, and then blah blah blah. Work out dH by dt. Well, dH by dt will be given by this. So what that means is, remember, in the previous video, dH by dt is given by this. In this video, we just worked out that dH by dt for the cylinder is given by this. So what that means is, at this precise moment in time, when the coffee is 6 inches above the bottom, the speed at which it's falling would be this. Okay, and then the speed and at this precise moment in time when the coffee is 6 above the bottom, the speed at which it's rising is given by this. Okay.